I think we can start.
Yeah.
Welcome, everybody, to this webinar. My name is Judith Kara, and I'm here with my colleague Daniel Linda. And
Hi.
we are gonna discuss customer-centric security for digital banks. And before we dive into the topic, I want to let you know that if you have any questions regarding that topic, you can put them in the chat. We monitor that and try to answer as good as we can. Ready, Daniel?
Yes.
Ready?
Go ahead.
Yes. Well, customer-centric security means that you put yourself in the shoes of your customers. And that means that you should understand your customer expectations. And customers expect digital services, and that's not special for banks, I would say, to be available basically 24/7. They want it to be simple to interact with the services. It should be easy to see your balances, to start a transaction, to get a loan, and so on. And they want to have a consistent experience over various services so that they feel familiar with the processes across those services. And they expect security, especially from banks. They expect banks to deal with their data and keep their money safe. And we're going to focus on the last part of the list, but it ties to the other parts as well, because security is part of the product. And security is a broad term. So we're not going to focus on all aspects of security, but on a special aspect, namely authentication authorization with Auth and OpenID Connect. And those are two protocols that have a lot of benefits. For example, they support many communication channels, meaning you can use it in various types of application, mobile application, web application, and you can even use it for use cases like call centers. It enables scalable authorization, meaning that you can authorize it, implement authorization with it in various services without having to contact a central authority. But authentication is still central. And the one that means that you can control the custom experience of the authentication process with Auth and OpenID. The security architecture that Auth and OpenID enable has two parts. There's 3 actors and 2 parts. One part is retrieving a so-called access token, and the other part is using that access token to gain access to the services, and this is the APIs. And the access token, that's a piece of data that describes a delegated access from the customers to the client. So the customer delegates its access to the client application. And this access, it's not unrestricted, but it has a scope. So it's for a certain service or certain features. And it's associated with data that we call claims. And these claims can be about the customer. So it can be personal identifiable information, personal data, or it can be about the access or the resources that the client wants to access, the application wants to access. And the important part here is that this data is opaque to the client. The client should not and does not have to know about those details. And client, in Auth terms, means the application. And there are various ways to get this access token. And the most relevant here in this context is the code flow. And it has those 3 parties: the user or customer, the client, as I said, the application that the user interacts with, and the trusted party, the identity server. And when the user accesses the client, the application knows that it needs to get the grant from the user so that it can access the bank's services at the later stage. And to get that grant, it returns authorization request to the user that the user's browser forwards to the identity server. And this sort of request is called a redirect. IT terms. And the authorization request describes for whom the user collects the grant, which means which client, which application should the grant be for, what should it contain, so that's the scope, what is granted, how should the grant be communicated, in this case, via the code flow, and where should the result end up, and that's at the redirect URI. And in order to give that grant and to issue that grant, the identity server needs to know who is giving the client the grant. So it needs to authenticate the user. And after a successful authentication, it can return a so-called authorization response. That's a redirect again to the client with a one-time code, the authorization code. And the client can then exchange or redeem this code for a reusable access token. In terms of customer experience, it means that the customer first accesses the client app and then forwards the user to the identity server. And this switch can be pretty seamless, as it was here, or it can be very obvious and be a completely different screen, for example, third-party apps where you want to make it clear difference. And whatever the use case, it's the identity server that controls this behavior. So if you can control the identity server, you can control your customer experience for the authentication. And as I mentioned before, security is important. So I would like to have a look at what can go wrong when you do that kind of flow. And it can go wrong at basically all the places. For example, at the user, that affects the authorization request, the authentication, or the authorization response, because all those messages pass the user's browser. That means an attacker could aim for changing the scope, requesting more access than intended. It could manipulate the redirect URI to get the authorization code. It could target the authentication process using click checking, phishing, and more. It could try to intercept the code in the authorization response and change it to, at the end, get the new token. And speaking of getting tokens, can also go wrong at the client, meaning that could be a malicious authorization request or a malicious token request from a client that pretends to be a trusted client. So I add client impersonation to the list of what can go wrong. And finally, it can go wrong at the identity server side as well, targeting, once again, the authentication or the responses from the identity server. We have, for example, a tag in the middle, or we could have a rogue identity server in the ecosystem. But luckily,
not
there's
to disturb your flow here,
yeah.
But we got a question. So
yes,
but I see that this is the next slide. So, but so you already know. But the redirect URI isn't that whitelisted. So
exactly.
How could that be misused?
Well, that's if there is an error in the logic on the identity server, then this could be a problem.
Yeah.
So that's it's in the core. It's in the core. So that's you wouldn't expect that, but that's still a risk factor that the protocol order addresses. So you have to validate the redirect URI, and that normally means that for each client, the identity server has a hard-coded list of redirect URI that are valid for that client, so that you can't send a code that's intended for that client to a different redirect URI. But implementations have proven. Yeah, exactly. Exactly. So you should use string comparison here, but it's not always very practical because sometimes would like to have dynamic redirect URIs. But that's if you use string comparison, that's a good countermeasure for that attack vector. Another mitigation is PXE, which protects against code interception. So it makes it harder, if not impossible, to switch the code in the flow for a different code. And another measure is to protect the token request and enforce client authentication. This means that to get the token, a client needs to authenticate and provide credentials. And ideally, it uses credentials based on asymmetric key like mutual TLS. There are more countermeasures targeting other messages like the authorization request. So you could also have the client sign or even encrypt the authorization request. You could minimize or you can minimize the data that you send in the redirect via pushed authorization requests. You can protect the responses in the same manner that you can protect the authorization request using JOT secured or using JOTs. But most of the time, it's sufficient to add an issue identifier to mitigate against certain risks with rogue identity servers. And you can find all of this in the FAPI security profile. So if you use the code flow with PXE, if you enforce client authentication with asymmetric keys, if you use pushed authorization requests and add an issue identifier to the responses, you have a good foundation for secure token retrieval. And that's, well, as we said, there are two parts. So getting the token is one part, but using the token is the second part.
Yeah. So using a token, but let's just start about the architecture around this. So we're talking about obtaining tokens with OAuth and an OpenID Connect, but how do we use those? So in Curity, we often talk about a token-based architecture, which typically means an application has a token, and with that token, it's allowed to call APIs. But if you go to next slide, in reality, of course, there's a lot of different APIs. And building a token-based security architecture means that all of these APIs must be able to accept a token to authorize these calls. So the interface of getting into this API is that I have a token issued by a trusted issuer, and here's the information that tells you I'm allowed to do this call. Well, trying to look ahead at the other slides, but this architecture makes it possible for the API of the authorization decision becomes the token. So if a client or application has been able to obtain a token for a specific user, we can have a token that describes, this is my current user, I am application A, and I have been obtained these permissions for myself, and here's the proof. So all the APIs can look at this token and verify it and say, and trust that information that comes with it, and base their authorization policy on it, making it easier to scale those types of APIs, because all we need to know is how to verify a token and also how to authorize each request. Also, in reality, there's more players around here, so that we can make like a layered authorization structure. So most companies have an API gateway, or at least some kind of perimeter into their APIs, making possible for this API gateway to make similar authorization decisions already before reaching the APIs. So an API gateway likely can have a more simpler policy, making a more coarse-grained authorization decision. But when we come to the APIs, we can make the more definite decision, because the API itself has all the business logic and knows exactly what the client is trying to do right now. Yeah, you can go to the next one. So a token-based architecture enables you to use a centralized user management and token issuance in your API platform, and keeping your authorization policies decentralized, and also makes it easier for you to have your users and partners and all of those having access to these APIs, because the interface for getting into your APIs are very consistent. It's easy for us to, since this being consistent, it's more easy to add new services. It's easier to update the policies. And we can reuse the techniques of validating the token across our APIs, even though there are several different types of languages in your APIs, the techniques are very similar. So it's easy for a product owner to define the way to authorize your APIs. So in many cases, or at least in the beginning of an API journey, you often keep the authorization decision very close to the source, being that your policy is probably in your APIs. But when we have already come to this place where we have this type of scalable authorization decisions, we can perhaps make the policy come from an outside source. But this still means that we have the same interface. We get all the information we need to base our authorization decision on from the token. It's just that making the actual decision can be offloaded to a centralized component, like an agent enforcing a policy or something like that. Yeah, let's go to the next one. So I mentioned the coarse-grained and fine-grained policies. For an API gateway to make a broader decision, it's often a good idea to make that contain as little logic as possible, so that the API gateway can make easy choices. So to come to API A, at least it needs the scope for API A. So we can just filter requests and offload APIs with bogus requests that we know that they're never going to allow anyway. So making that coarse-grained authorization decision being just a policy that says you have to have a valid token and it has to have this scope. But after passing the gateway, coming into the API can of course look at the whole contents of the token. So looking at the claims describing the user. So Daniel is an admin user, so he's allowed to call this API with this application, taking the whole contents of the token together with the request to see, are you allowed to do this or not? Making that the fine-grained authorization part.
I think we have to back a bit. We got the question about Pixie and PAR. And Pixie, and I answered that live because it's hard to answer that in text. But Pixie binds the authorization request to the token request. And in PAR, they are still decoupled, right? So you could have a PAR request, it generates an authorization code, and then you should know in the token request that the authorization code that you send comes from the same user and browser that just started the flow. So you still need Pixie in PAR That's a short answer.
Yeah.
Mm,
Should I take the next one then about the token
yes.
architecture? Looks like one key point would be then that a token becomes a transient credential for authorization purposes. And this token is flexible to account for multiple variables to enforce during the authorization. Well, that's pretty much it, right? So the token becomes a credential for the application, but it's a temporary credential. It has a shorter lifetime than a typical credential, and it can be flexible to contain different amount of data depending on the current operation. So for accessing a user profile, we probably only need to know the username to allow you to access to that specific username. But for making a payment transaction, we need something entirely different. You might need like the amount you're allowed to, the amount of money you're allowed to move with this specific token. So I agree that it is a temporary type of credential.
And it has different formats.
Good. Yes. So since these tokens can contain a lot of different types of data, they can also be personable, identifiable information. So we don't want them to leak to all different places. Only the types that need them should be able to see that personally identifiable information. So we know if there are different token formats that to describe these tokens. We typically divide them into two classes, meaning OPAC or reference tokens or by value tokens. So either they're a reference to some data or they're the actual value of the data. So OPAC tokens are reference tokens. They're typically serialized like a random ID. So you get a random ID to your client and you can bash out it for as long as you like. It will never mean anything to you. It's simply a pointer to a database. And the only one that can dereference this is the OAuth server. But structured tokens.
Yeah, and the auth server, that's the identity server. We haven't introduced the term auth server, but that's the identity server.
Yeah, true. So in any case, security. So here, and the structured tokens being the opposite then, the value of the actual tokens are typically used as JSON web tokens, which are most often signed plain text data. So it's easy to read them, it's easy to parse them, it's easy to validate them, but we can, which makes them powerful for the correct players, but also might be too powerful for other players. So we need to make sure that JSON Web Token is only delivered to the parties that need it. And we have on the next slide as an example of how we typically do with in Curity, trying to make this type of privacy preserving architecture where we're keeping OPAC tokens on the outside of the API gateway. So clients always get OPAC tokens. You can never read what data that's in them.
Yeah,
but
and as we said,
yeah.
Sorry, and as we said in the beginning, it doesn't have to have access to the data either. It's the APIs that need the data for their access control logic.
Exactly. So access tokens are not issued for the client; they're issued for the APIs. So they should never be able to read it. And using an OPAC token is a natural way of hiding that data. But keeping an OPAC token all the way to the APIs would mean that all the APIs that are supposed to read this access token have to dereference it with the identity server. So instead, we allow the token to be of the form of a JOT on the inside of the API gateway. And I think Judith want to explain a little bit more about how that could work.
Exactly. That brings us to a couple of gateway patterns. So how can we enable or implement this form of privacy preserving architecture? And we have identified 3 approaches that we call the phantom token approach, the split token approach, and the wrapped token approach. And in the phantom token approach, the API gateway is responsible for transforming the incoming opaque access token to the JOT access token. And it can use a form of token introspection, or it can also use token exchange. And the way it works is, well, pretty simple, pretty straightforward, I would say. So the client sends the opaque access token in its request, and the API gateway translates or transforms the access token with the identity server to get the JOT access token that it then forwards to the APIs. So we have the opaque access token on the client side and the JOT access token on the API side. And it can optimize by caching the JOT access token. So it doesn't have to call the identity server on subsequent request, but can cache the JOT as long as it's valid and just look it up in its cache. The other approach is to divide the JOT access token into two parts, in the signature part that is opaque, and into the other part, the header and the payload. And then the API gateway is responsible for assembling the JOT access token. So the first step is to split up the access token. So when the identity server issues the access token, it creates a JOT access token, but it only returns one part to the client that serves as the opaque access token, and it forwards the other part to the API gateway that caches that part. So when the client sends a request, it sends this opaque access token that the API gateway uses to look up the other part in its cache, puts the parts together, and forwards the full JOT to the APIs, so that the APIs still can work with the JOTs. And the third pattern is a bit different because there we wrap the opaque token and in a JOT and add some data to it. Then the API gateway is, as in the phantom token pattern, responsible for transforming this incoming access token. But since this incoming access token has some data, contains some metadata, some minimal data, the API gateway can perform some decisions. So it looks pretty similar to the phantom token pattern, with the difference that the opaque access token has some data associated with it that the API gateway can process before it exchanges the token for a JOT access token that it forwards to the API. And this pattern is very useful to implement dynamic routing, for example. So you can have some data like a region field associated with the opaque access token. So when the API gateway receives that kind of token, it can look at it because it can parse it. It can check the claims, and it can process logic, such as routing it to the dedicated region. And that region could have its own API gateway and do the phantom token pattern, but I decided to have it in one. We have some questions. In the phantom token flow, what happens if the opaque access token is revoked, but the cache remains valid? How to handle those? Well, if you cache it in the API gateway, you would cache it as long as it's valid. So if you revoke the token, you would have to inform the API gateway to clear its cache, or you would have to integrate with the cache directly. So you would have to have some event-based logic to update the cache of the API gateway. If you don't do that, if you don't inform the API gateway about this revocation, it will accept the access token as long as it hasn't expired.
Which might be valid in some cases. If you use short-lived access tokens, say 3 minutes, it might even be valid to let it live for that long, even.
Exactly. So you can minimize the impact and say, well, I have very short-lived access tokens, so if they get revoked in this minimal time frame, it's acceptable. I can live with accepting access token for 1 more minute. But then the question is, why would you revoke it anyways if it doesn't have any effect? But that's a way to deal. Yes, that's a way to deal with it. So we have now talked about retrieving access token and sending access token. And one part that we haven't covered yet is the trust relationship with the client and how to establish that one. Damian, do you want to?
Yes, we have a question there that came in just before you left it to me, but I can try to answer.
Yeah.
If the access token only contains entitlements without any PII, why should it then be kept secret? So kept secret, I'm assuming you mean keeping the actual claim values a secret. But the thing is that token data change over time. So if we're sure that we're never ever going to change the tokens to contain any PII, then we can live with other types of patterns. The phantom token and the siblings enforce that we never put PII in tokens that reach to clients.
The access token could also reveal not only PII, but like internal information. So whatever you put into the access token is information that an attacker potentially can use against you. So even if it's not like sensitive information like PII that's regulated, it could also be internal information that you don't want your customer, want an attacker to know, like endpoints. Often there you have an audience in the claim. You have, or in the token, and you have different data that could give an attacker an insight.
Very
so
true.
It's not only PII that you want to not reveal, keep secret.
No, exactly. So just the fact that there's scopes, that means you have access to a certain part of the system might be valuable to hide. But talking about the trust relationship, so a typical OAuth client or application has to be pre-registered with the identity server or with the OAuth server to say, I'm going to use CodeFlow to talk to you. This is my redirect URI that you're going to use and verify that's going to be used. The OAuth server generates a secret for it, something like that. So being a pre-registered client means that you're a trusted client. So we can say on the server side that this client is only allowed to ask for certain scopes. It should have only these claims and things like that. So a statically handled client can be made in a API management portal or something like that. But in many use cases, that this is not feasible because we want to be able to integrate with multiple different types of identity servers, and we want to make it a self-service registration that's programmable. And so in open banking movements, I often talk about dynamic client registration, which is a specification that describes an API for a client to register themselves. So basically a REST request saying, I am a client, I have this redirect URI, I have this metadata, and I want to interact with you. And the server accepts the call and gives you back a secret to use in subsequent calls. So the hard part about that is typically to protect that API and only allow clients that you want to have in your system to register those types of clients. So in open banking, that's typically based on an util-less channel, or at least some kind of certificate authority that provides the trusted third-party clients with some kind of key material that they can use to their IDPs that are part of the federation to register the client. So, for instance, UK open banking, you make a util-less call with an ADA certificate, and now you're allowed to register your applications. So this has to be made to every type of IDP that you want to integrate with. But it works as this picture. The identity server and the client have a common denominator being the trust mechanism, ADAS in the EU open banking movement, where the client has been issued key material and the identity server trusts key material issued from this authority.
And the client has to register or at the identity server before it can start the authorization request.
Exactly. And it has to
Log
do
in.
it for every instance you want to interact with. So if I'm a finance scraper type of application, I have to register at all banks, and I need to keep track of all the different credentials that these banks are giving me to interact with their system.
So what's the
before I
alternative?
can start it. Alternative would be something similar. If we go to the next. There's two slides here that I want to talk about, but one being an attestation-based onboarding. A client can be issued a key material from a trusted party of some sort, but instead of having them go and pre-register at each IDP that they want to use, they can use it in their authorization request. So they make an attestation that they hold the private key of the material that was issued from the trusted authority in the authorization request, basically sending a proof of possession saying, I have this key, now let me in. Which means that the identity server can then verify the attestation and see that this belongs to a key issued by my trusted authority. So we don't need to pre-register ourselves, but the client instead sends all that metadata in the authorization request in the form of a signed JOT. If you go to the next one, there's a big new spec that's almost final, I think, which implements a flow similar to this. We call the OpenID Federation. So this, of course, talks a lot about how to use OpenID in big federations, but it has an applicability in open banking as well, because they define a more or less a PKI around how this key material issued by a trusted authority can be trusted by all the parties inside of a federation. And we get all of that benefit of no registration just by my client obtaining an entity statement from a trusted authority and publishing it on my own endpoints, so that a bank or other interesting parties can view it and make sure that this party should be a part of this federation and should be allowed to access my APIs instead of using this pre-registration.
And that simplifies the flow, right?
Yeah, exactly. So it's still the same type of trust in between the client and the server. So the server doesn't really trust the client; it trusts the authority that gave them the keys. But we don't have to force the client to register before accessing my APIs or authenticating your user.
And the benefit here that you told me before in the preparation for the webinar is that the client doesn't have to maintain different client IDs as in DCR. Because when the client registered with the dynamic client registration, they receive the client metadata from the server, including client IDs, which means that they get a different client ID for every identity server they integrate with, for every bank they integrate with, and they have to maintain that. So that makes it much easier to implement as well.
For sure. Thanks for reminding me.
Yeah,
but I think that this OpenID Federation is, of course, not. It's still in the growing. So OpenID Federation is been rolled out in several places, but we do see some indications that this might come into the open banking world as well. And the attestation based on the previous slide is something that's being used in verifiable credentials. So these types of schemas are coming out and are going to be used more widely.
Yeah, we have. Speaking of authentication and trust, we should also authenticate the customer. And that's actually so important, and that there are regulations around that. So strong customer authentication is a term in the PSD2 regulation, which basically means you need to use multi-factor authentication. So it's not enough to just have a password and authenticate your customers with a password. You need more. Then you need also to provide something that they own or something that they inherit, like biometric identifier. And often it boils down to asymmetric keys again, that the users or customers unlock either by a PIN, something that they know, or a biometric identification with the finger or the Face ID, so that they can provide that they also own the key. And the experience differs a bit depending on how or where the user authenticates. So the user customer can authenticate on the same device, and then the application can just open the system browser with a redirect where the user can enter their credentials and log in. But it's slightly different in a cross-device flow where the customer can't enter their credentials because either there is no input method, or they are not physically not in place. They're just calling a call center, and they're not sitting on the other side. So there you have a decoupled authentication. And there is a standard called the device flow, and that targets those cases where the user is physically present, but the device has restrictions. For example, a TV where it's hard to enter some credentials, or an IoT device. But in open banking, you have a different protocol, the client-initiated packet channel authentication, which works similar, where the client initiates an authentication request, and then the identity server out of band informs and notifies the customer to authenticate. So in this case, the client has to collect some user identifier, some login hint, as it's called in the protocol, so that the identity server knows who to notify. And then it can use any proprietary protocol to implement the authentication. And that's actually pretty, I would say, common in OAuth, that the authentication part, that's proprietary. And when the authentication is done, the client gets a notification from the server saying, well, I have authenticated the user. Here are your tokens, or please get the tokens, depending on which flow. And this is basically these are the methods that you have when you deal with trusted third parties. It's slightly different if you have first parties, then you have more options.
Yeah, exactly. So OAuth has traditionally always talked about, or more or less saying that all clients are third party, but you often want to make a nicer UX for your own banking application than for your third party that's just scraping your data. So a lot of different types of usages has been made, but there's an ongoing spec for specifying how this could be done. So the OAuth for first party applications is a way to just start an OAuth flow and then going over to an API-based authentication, more or less. And then when you're done with the authentication, come back and obtain your token. A pretty slim spec, but it's something that we have been waiting for it, more or less. Yeah.
Yeah, I think the main difference here is in the browser-based and the redirect-based, or even the cross-device flows, it's the identity server that dictates the customer experience. It's the screens of the identity server that you see when you log in the redirect. But here it's in the application, right?
Yeah, so that's a difference. That's a difference for being in the API, but just for coming to that part, that's the specification part. But in Curity, we have an API called the Hypermedia Authentication API, where we give the application the possibility to render those screens, as you were saying. But we don't want to take away the benefit that we have when we're running in the browser, where the server can dictate everything that is happening. So it's always rendering HTML pages for you to see. These are the methods you're allowed to use. I want to ask you your username and password now, or use a national ID, something like that. When we're in the browser, that's a very easy thing to do. We can allow you to change the workflow for the user in runtime, more or less, without having to update your iOS app to be able to accommodate for the new changes. So that's something that we need to keep when we're coming over to the API world, which is why Hypermedia Authentication API is Hypermedia. The API is a JSON-based API where each response contains information of what the application should render, but also where to go next. And since this is a live API and the different models are well defined, we can implement SDKs for these applications to be able to render these things more easily. And that means that we then can more easily change configuration on server and still having that it update the app without going through an app store update for everything to go. But we're still in a native implementation, so we can take advantage of native APIs for Face ID or things that we need in an app to make an authentication workflow happen, and make it feel more native to your app than popping up a web browser and logging in that way. Yes, talking about workflows. Workflows, authentication workflows is a broad term, but in Curity we talk about the user journey through authentication. So typically an authentication is not about me giving my username and password. It's also for the possibility to check in a user database. Are you, what groups are you member of? What extra factors did you say you wanted to enter? And ask, did you accept our terms of agreement? So if those things tells us that we need to show extra screens for the user along the way before we can authenticate the user, that's a workflow. So it's a way to make custom authentication workflows that we can use to obtain all the information that we need about the user to make a secure authentication. It can also be adapted, saying that this user was logged in the US 2 hours ago, now is in Sweden. So perhaps we should ask for an additional factor here, because we're not really sure that this is possible. But in an authentication workflow, we can also add on things like pattern recognition to help prevent fraud or detect bots or anything like that. So this is just the whole umbrella of authenticating your users in a secure way.
You can have different steps, different factors.
Yeah. So this is a screenshot from our admin UI where the user is, the authentication method is in the middle. Let's say that's a username and password method. But if this is the first login, we need to go from right to left in all of these boxes and make sure that the user passes all of these hoops before they actually logged in.
Which means you're at the end of our webinar.
Yeah, a long slide deck, but we did talk some about the token-based architecture and how that enables the scalability that we've been talking about, and making it possible to have these both centralized but decentralized authorization decisions, and help fraud detection in your authentication workflows. So what do you think, Judith? Did we talk about anything more? Anything you want to add?
I think we covered everything, and we are over time, so I think it's
we've been talking about. It's good. So
if not, this is your last chance for any questions. Otherwise, we wish you a very pleasant day, evening, wherever you are. Thank you.
Thanks a lot. Bye.